So instead of using Pythagoras as I did in the previous example, I could have used the Pythagorean identity to be able to solve for a different trig ratio. What do I mean by that? Well, let's have a look. We've been given that cos of A is 0.75, A is between 0 and 2 pi, and I need to determine sine of A correct to 3 decimal places. So I've been given that cos of A is 0.75, and I'm interested in A between 0 and 2 pi. Let's see what happens when I use this Pythagorean identity. So using the Pythagorean identity, and that is that sine squared of A plus cos squared of A has to equal 1. So that means I've got that sine squared of A plus cos of A all squared, so 0.75 squared has to equal 1. So that sine squared of A is going to be 0.4375, and that means I can take the square root, so sine of A will be plus or minus the square root of 0.4375. So sine of A will be plus or minus 0.661. And I need to just justify what I'm doing there. So let's just have a look in our unit circle. Notice that originally, this is where I'm getting my original, where my angles are. Cos is positive, okay? So cos is positive in quadrant 1 and quadrant 4. Okay? And when I then link it to these two solutions, so therefore sine of A is positive in quadrant 1, and in quadrant 1 sine of A will be 0.661, and sine of A is negative in quadrant 4, so my solution in quadrant 4 will be negative 0.661.